Here we go. We have a question, two swaps. So you have given a permutation of some of the first natural numbers in an array, and we need to determine if the array can be sorted in exactly two swaps. So we need to do two swaps, not more than that, not less than that. A swap can involve some pair of indexes twice, and we need to return true if it is possible, else we need to return false. In this case the answer is yes, because if you swap this and this value, then you will have 1 3 2 and 4, and another swap is to swap this and this value, so the array will become 1 2 3 and 4, and we have to do two swaps. So in this case the output is true. In this case we cannot perform exactly two swaps. Why? Because here the output, here the input value, one value have to be here, then this 4 value will have to be here, then this 2 value will have to be here, this 3 value will have to be here. So that's how we need to perform. In this case we need to perform more than two swaps. So let's try to build the approach. So I have taken this example. In this example, we have a permutation of value 0, the indexes is 0 to 4 and the values is from 0 to 1 to 5. So this is the permutation, and as you can see the element is equal to the index plus 1. So it is element, it is equal to index plus 1. So in this case, how many different values are there? How many incorrect elements are positioned? So in this case, let's check. This is the element and it is equal to the index plus 1. So in, initially our count, we have a count and it will count how many elements are disaligned. So initially it is 0. This is valid, this is valid, this is valid, this is valid, and this is valid. So our count is 0. What it means is, if you swap this and this value, we need to perform two swap no matter what the case. So if I swap this and this value, it will become 2 and 1. If I do another swap, I will perform the same swap on the same, I will perform the second swap on the same number of, on the same elements. So if I do this, our element is sorted, our array is sorted. So if count is equal to 0, the answer is true. Let's check for another case. We have this case. So this is our count. It is equal to the element is equal to index plus 1. In this case, it is not equal. In this case, yes, it is equal. Then in this case, it is not equal. So our count is 1. In this case, it is also not equal. So uh, our count is become 2. Now it is equal to the index plus 1. So we need to check element, is it equal to the index plus 1? In this case, our two values, our two elements are on a incorrect position. So if I do this and this, 3 here and 4 here, so I have performed only one swap. Our array is sorted now. So if I do another swap, the array will become unsorted. So if our answer is 2, if our count is 2, the answer is false. We cannot perform no matter what's the permutation. If our count is 2, we cannot sort the array. So let's try to implement same for this test case. Count, it is the element is equal to index plus 1. Yes, in this case it is not correct, so 1. In this case it is not correct, so 2. In this case it is also not correct, so it is 3. If our count is 3, so we have this and this element, we need to swap. So if I swap, let's determine how we can swap. So if I swap this and this first, this and this, so this element is sorted, means our element is equal to index plus 1. In this case it is valid, in this case it is valid, in this case it is valid, only this and this condition is not valid. So we need to perform another swap. So if I do this 2 and 4, so now it is valid. So we have performed two swaps, so our answer is valid. If our count is equal to 3, count is equal to 3, then the answer is true. So let's try to implement. For the next test case, we have this. In this case, it is not valid. Our count will become 1. In this case, it is also not valid. Count will become 2. This is also not valid. Count will become 3. It is also not valid. Count will become 4. If our count is equal to 4, so this is the important case. We have checked for 0, 1. If our count is 1, it is not possible because the element is a permutation. So one element is incorrect. That does not make any sense. Either this is a permutation. So if this is a permutation, the element is only disaligned. So 1 is impossible. Then 2, 2 is false. It is true. Then 3, 3 is also true. Then 4. Then 4 we have to check. Then 4 onwards, the answer is wrong. We cannot uh, sort the array. So for 4 we have to check. Why? Because we have A, B, C and D. These 4 elements, these 4 indexes is invalid. In this case 1, 2, 3 and 4. In this case these 4 indexes is invalid. So either this element have to be swapped with this element. So it will become B and A. Then it have to be swapped with this element. So it will become D and C. So we need to perform only two swaps. If after doing these two swap, if the array is sorted, means if I perform this, then these two indexes will get sorted, have to get sorted. So if this is the case, if this is the case, if I swap A with B, or if I swap A with B, or if I swap A with C, if I swap A with D, if either of these three condition is true, which means our two elements is positioned correctly. Then if two element is positioned correctly, we need to perform one more swap, then another swap. Only two indexes is in incorrect position. If I do a swap, the two indexes will be placed in a correct position. So we have to check for either A is equal to B, or A is equal to C, or A is equal to D. So we need to check the indexes first. We need to first find out the indexes. So let's find out the index. In this case, this is not valid. So we know our count is 4. So I will build a separate function if our count is 4. So we have to check A, first A store -1, B store -1, then C store -1, then D store -1. So this position is incorrect. So we store the index in first, in variable A. Then this position is also not correct. A value is already stored. We store the index in B. Next, this position is incorrect. We store the value in C because A and B is already storing a value, and the variable is -1, is not -1. Then we have this. Then fourth value is this. So we store the value here. So now we know our these four indexes is incorrect. So we have to check. If I swap A with B, will A and B element will be in a correct position, or if I swap A with C, the element will be placed in a correct position, or if I swap A with D, the element will be in a correct position. So we have to check for these three conditions. So let's check. If I swap this and this, we do not need to perform the swap. We just need to check. So I am not changing the input array itself. So we have to check. This element is 2. This element is 2. Is it equal to, if I swap this, the element will be here. So if the element will be here, which means its index is b, its index is a. The variable, the element is present, at I is equal to 2. Is it equal to b plus 1? Yes, this is the case. And means this element will be in a correct position. We also have to check this element will be in a correct position or not. So this is valid. So the element present at index b, is it equal to a plus 1? So it is 1, and it is 1, the value is 1, and a is 0, a plus 1 is 1. Yes. So if I swap this and this, it will become it will be in a correct position. So no need to check for the other element, because only two elements are in a incorrect position. So if this only is valid, so this is also satisfy the condition. Means only two elements is in a incorrect position, and we need to perform only one swap. So it's automatically in a correct position. So we have to check just for this. So in this case, it is valid. So let's change the input. So let's say, um, let me change the input. So let's change the input. 4 3 2 1. So these four elements is in a incorrect position. Our A, B, C and D stores the incorrect position. So let's first remove the unnecessary things. So we need to check, if I swap this and this value, will it get sorted? So the element present is here 4, and if I increment, so this is variable b, if I do b plus 1, it has to be equal to this. No, it is not. So a and b does not satisfy. Then we have to check a with c. So if I swap this and this value, so let's check the value present at this index is 4. It has to be equal to c. It has to be equal to c plus 1. Is it equal? 3. No, it is not equal. So this condition is also not valid. Let's check for next condition. So now we are checking with d. So the value present at this index means ARR of A. It has to be equal to d plus 1. Is it equal? So let's check. D plus 1, 4. Yes, this element will be in a correct position. We also have to check this with this. So the value present at this value is d, and it has to be equal to a plus 1. The value is equal to 1 and a is 0, then a plus 1 is equal to 1. Yes, if I swap this and this value, so this is valid. Means if our count is 4, these three condition, either of these three condition have to be valid. In this case, third condition is valid. So our we can do we can sort the array by using only two swaps. So let's code this. So first I have count and n, then I have a for loop. Is element not equal to index plus 1, so we need to increment the count. 0 is valid, 1 is impossible, 2 is false, 3 is valid, and 4 is skeptical. If our count is 0, answer is valid, or count is 3, answer is valid, or if our count is 4 and we need to verify our array. So these three conditions have to be true. So this is the verify function. We have four indexes, four variables. It will store the four indexes. We have a for loop. if the element present at this index is not equal to index plus 1. If a value is not stored, we store the value in A. Then if B value is not stored, we store the index in B. Same for C and same for D. Now we know 4 indexes that are invalid. So we need to verify the swaps. So we have a function verify swap, first A with B or A with C or A with D. So let's check out this function. We have this function getting list I and J index. We need to check, is the element present at I index, this is the element, is it equal to J plus 1, and the element present at J index, it has to be equal to I plus 1. So that's the code. We have not changed, we do not need to change the input array itself. So let's give it a try and let's talk about time and space complexity. In this function, first we have this function, the time complexity is order of n. Next we are doing one more iteration, it is also order of n, this is constant. Then the overall time complexity is order of n and space complexity is constant. So we have met the time and space, yes, here we have met the expected time and space complexity. The code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.